Welcome to my class. Today we are going to discuss about two topics. The first one is Pythagoras Theorem or Pythagorean Theorem. Generally, we need a right angle triangle. In this case, it is applicable in right angle triangle only. So let's draw a right angle triangle. The base is equal to A, perpendicular is equal to B, and the hypotenuse is C. Then according to the theorem we can say, let me name the point, that is A, angle A, B and C. When here AB equal to base, AC equal to perpendicular and BC equal to hypotenuse. So in that case, AB square plus BC square, AC square equal to BC square, that is base square plus perpendicular square equal to hypotenuse square. Here base is A, so A square, plus perpendicular is B, so B square, and hypotenuse is C, so it is C square. This equation is called Pythagoras theorem. From this we can determine the hypotenuse. So C equal to A square plus B square. So of a right angle, if any two lengths are known, then we can determine the third one using this formula. Now let's see an example. This is also a right angle triangle. The side are ABC, AB and base is BC. AB is 3, given 3 cm and BC is 4 cm suppose. So we have to determine AC, that is hypotenuse. Here we will apply the Pythagoras theorem again. According to the formula, we can say AB square plus BC square equal to AC square, that is base square plus perpendicular square equal to hypotenuse square. So here AB equal to 3, BC equal to 4, so 3 square equal to 9, 4 square equal to 16, so AC square equal to 9 plus 16, so AC square equal to 25. From here we can determine AC root over AC square equal to root over 25. So AC equal to root over 25 is 5 into 5, root over 5 into 5, that is 5. So it is 5 cm. So if we need to understand how the square and square root is done here, then we have to know about the square and square root chapter, and my second topic is square and square root. If you follow the book R.S. Agarwal, it is I think 4th or 5th chapter, and I am giving some formulas and sums from there. So we have to know the square of some numbers, that is 2 square equal to 4, that is 2 into 2, 4. 3 square equal to 3 into 3, that is equal to 9. Therefore we can say n square equal to n into n. N is a natural number. N is any natural number. So from that we can say square of a number means multiplying number by itself. Square of a number means multiplying number by itself. That is, if we multiplying 2 into 2, that is 2 square. If we multiply 3 into 3, that is 3 square. If we multiply 4 into 4, that is 4 square. So if we multiply any number with that number again, then we get the square. Let's see an example, that is 13 square equal to 13 into 13. So that is 169. You can determine the square of any number between 1 to 20. It will help you in future. Now let's go to the topic square root. Square root is just the reverse process of doing square. When we write root n, the value of root is half. So we can write it as n to the power half also. Now let's take a number that is n square. Suppose a number is already a square, so we can write it as n square and into half, because the value of root is half. So it is n to the power 1, which is equal to n. As example, let's take a number. See, it's root 25. So we can say 25 to the power half. So we know that 25 is the square of 5. So it is 5 square into half. So 5 to the power 1, that is 5. In this way we can determine the square. But in our daily life we generally follow a simple rule. We can just say that root 25 equal to root 5 into 5, and whenever we make a equal pair, we have to just put one outside the root. Okay. We are pairing this. I will show you more example later. So one number will be out from the root. So root 25 equal to 5. You can find the square root of any other number like this. As example, take root 64. That will be the square root of 8 into 8, that is equal to 8. Now let's read some properties of square root. Here it is. I have seen these properties in the book of R.S. Agarwal in the chapter square and square roots. If x square equal to y, then we can say x square and y are two numbers. We can say x equal to root y. Okay. Next, here is the second property. I already wrote it here. That is root over n square equal to n squared to the power half. That is n. Number 3, third property, root over xy equal to root x into root y. Now fourth property, root over x by y equal to root x by root y. So here are four main properties. We can remove the square root of denominator part by multiplying the same number in numerator and denominator in this way. If we take the same number, then it will become root over x into root over y using the third property. And root y into root y, that will be y. So we can say it is root xy by y. This is also an important property. Now let's see some example of each properties. So here example of the first one. Let x square equal to 9. So using this property we can write x equal to root 9, that is equal to 3. Now the next one, root over, let it 16 square. So we can say 16 square to the power half. I have already shown this one, so this is 16. Now this one, suppose it is 64. We can write it as 16 into 4. Both are square numbers, 16 and 4. So it is root 16 into root 4 using that property. So root 16 equal to root 16 equal to root 4. Root 16 equal to 4 and root 4 is equal to 2. So the answer is 8. See, from this side we can directly write it as 8. So if it is assumed as right hand side and if it is assumed as left hand side, both are equal. Hence the property is proved also. Similarly, if we take this property, similarly we can write root 16 by root 9, that is equal to, we can write it separately as root 16 and root 9. So it will be root 4, it will be 4 by 3. So RHS equal to 4 by 3. Similarly, LHS is also root 16 by root 9, that is 4 by 3. So RHS equal to LHS. In our next class, we will discuss more. Till then, like, share and subscribe my channel Study with Sayanti. Thank you.